Okay, I will do one example and then you can have a go after that. So here you've got one fraction here, merge it with this one here. So to do this, well, remember we don't really care about these two here. We only care about the two denominators. Somehow get them to be the same. So what do you need to times top and bottom by in order for them to be the same? So here you just again here I think you just got to use your own technique here. I'm somehow I'm going to have to get the two denominators to be the same. So I'm going over on this side. I'm going to times top and bottom by 4. Okay, because I look ahead and see. Look at the 2. You've got the 2 here and the 8 here. So I know if I get something somehow, so it has an 8 on this side. So it will be 8a whatever on this side, and on this side 8 whatever. You can see the 8 is in common here. Okay, well anyway, I just know on this side I've got to times it by 4 something. Hang on. So look ahead. Now look at the a to the power 3, a to the power 4. So I need another a squared here. So I know I'm going to times it by a squared. And then on this side, look at the b to the power 7, b to the power of 2. So I've got the b is in excess at the moment. So it's that I've got more b's than I need, because well over here in effect I will need to times it by b to the power 5, because I've got more than enough b's over here. So I'm just going to times top and bottom by 4a squared on this side. Okay, on this side, well I've got more than I need for the 8, because over here there's only 2. So I'm going to times it by 1, but let's not bother about the 1, because 1 times anything is just 1. Well, when it's 1, forget about it. Okay. Now let's jump to the a to the power 5 and a to the power 3 over here. Over here, I've got more than enough, more than I need. So over here I need a squared, which I've done. Okay. So on this side, I don't need to times by the a. Look at the b here. I've got b squared, and over here I've got b to the power 7. Over here I need an extra b to the power 5. Well, anyway, I'm going to times it by b to the power 5 here. Okay. So hang on. Let me just tidy this up. So remember, over here I'm times the top and bottom by b to the power of 5. Okay. You just have to develop your own technique here. And here I'm going to times the top and bottom by 4a squared. Okay, 4a squared. Okay, so now let's so this fraction here becomes well hang on, let's do the bottom part first. The bottom part will be 2 times 4, which is 8. Okay, and then the a times with the a here, which is a to the power 5, and then you've got b to the power 7. Okay, and remember our plus. This is a plus right here. Okay, over this side, well, let's get this times this. This will be 8 a to the power 5, b to the power b times b here, b to the power of 7. See? Can you see that the two denominators are the same now? So later on we can merge. Now it's just a matter of getting 7x times 4a squared. Well, 7 times 4 first. Do the numbers first. So it would be 28. And then keep it alphabetical. So it's this a squared x. Okay? And now 5x times b to the power 5. So 5 b to the power 5x. Okay, we don't really care about what's on the top here, but the important thing is the two denominators. So they're the same. So let's merge them. So this would be this to the power 7. This would be 28a squared x plus 5b to the power 5x. Okay, and then have a quick glance to see if you can simplify the top part. This is your Liga this is your Lie graph. They're two different things, so you can't merge them. So just leave it as it is, like this. Okay. All right. Now it's your turn. So this thing here, just somehow concentrate on the. Well, here you've got two fractions. Somehow merge the two fractions, but concentrate on the denominators here. Somehow get them to be the same. Okay, so press pause and have a go. Okay, so we've got it times top and bottom here, and then over here top and bottom to get the two denominators should be the same. Look at the number. Try and work out the number first. Here you've got 10. Here you've got 2. I'm going to times it by 5 over here. 5 something. Okay, that will, and then look at the A here, A here. There's more than enough over here. More than enough A over here. Here I've got 3 A to the power 3. So I'm going to need to times this by A to the power 3 again, because later on A to the power 3 times A to the power 3, that will give me A to the power 6. Okay, so if you look at this here, A to the power 6, you've got more than enough. Here you've got A to the power 3. So you need to later on you need to times A to the power 3 in order to. Well, anyway, so let's jump to B now. B to the power 2, and over here you've got B to the power 5. So over here, I will need an extra B times B times B. I'm going to need this, B to the power 3. Okay? So here, this is done here. So times top and bottom by B to the power 3. Over here, times top and bottom by 5A to the power 3. Okay? So, hang on. So to merge the two fractions, it would be like this. Now let's do this. This thing here, well, this thing here times a B to the power 3 will be 10 A to the power 6 B to the power 5. Okay, and then over here, this times this here would be 10. Well, 2 times the 5 here. The A to the power 3 times A to the power 3, which is A to the power 6. And then you've got B to the power 5, well, just B to the power 5. Okay, and now you've got to get this times with this. So this would be 3AB to the power 3. Okay, and then you've got 5B times 5A to the power 3. So get the number times with the number. So that will be 25. And then B times A to the power 3. Well, try and keep it alphabetical. So it's this. Okay? So what I'm trying to say is that this fraction here is the same as this fraction. This fraction here is actually the same as this fraction here. So, now that the two denominators are the same, we can merge. So 10A to the power 6, B to the power 5, and then on top it will be 3AB to the power of 3 plus 25A to the power 3B. Okay, and then have a quick glance to see if these two denominators are the same. Actually, most of you probably think they are the same, but they're not, because here, if you look at the breakdown of this, if you look at it, this is A times B times B times B. Okay, and then over here, if you look at this, here's A times A times A times B. If you look at the two DNA, if you like, of these two, they're actually different, because if you have something like over here, if it's B times B times B times A, then they're the same. Then these two would be the same, but it's not. Down here, it's actually, if you look at the DNA of this thing here, it's actually A times A times A times B. That is different from A times B times, A times B times B times B here. Okay, these two are actually different. They're not the same. Okay, if you have someone, if you have this here, A B to the power 3, and then over here you have b to the power of 3a, then they're all the same. Here, can you see that? Here, you visualize it like this. At the moment, you've got a times b, b to the power of 3. If you switch these two around, then yes, they're the same. If you switch these two around, but these, remember here, we're not switching them around. They're totally different. They're totally different because here you've got 3 a's in here, and here you've only got 1a. Okay, so here, what I'm trying to say is that this is different from this, so you can't merge them. Okay, so this would be your final answer. Okay.